Hi there, I'm Scott Lowe at ActualTech Media. I'm here today with Jason Baudreau, who is a Senior Product Marketing Manager for NetBrain. Jason, thanks for having us again.
Thank you, Scott.
So tell us about what adaptive network automation means to me, the lowly network administrator.
So, good question. So network automation is kind of a hot thing happening right now based on the complexity, the size and scale of enterprise networking. I think most organizations know that automation is the scalable solution to enterprise network management. Adaptive network automation seeks to address the challenges associated with every network is unique, every network task is unique, and how can we leverage automation to sort of fit into those workflows? So we employ what we call as a dynamic network map as the foundation for that automation platform. Through that dynamic network map, engineers can isolate a part of the network that they need to perform an automation task on, or any sort of a workflow. We have a technology that runs through the dynamic map. Really, most critical component to automation is an automation workflow. We call it executable runbook. So a runbook is really a sequence of events. It's a process or a guide, and every step in a runbook can be executable, which means that automation is powering that, leveraging the map as the input and as the canvas for the output. These executable runbooks can be used to integrate to existing workflows, and so NetBrain also has a series of rich APIs which can integrate to various network management systems. For example, your network monitoring system, your ticketing system, your security intrusion detection system, enabling that dynamic map, one, to be the single pane of glass for all data network management, and number two, to sort of trigger automation based on characteristics performing outside of the network or outside of NetBrain. For example, your intrusion detection system picks up a security event. NetBrain can trigger to map out the path of a potential DOS attack, for example, and then automate a series of tasks to understand the impact of that DOS event. Same thing with troubleshooting. So we call it visualize, automate, integrate, and it really powers adaptive network automation.
So it sounds like it allows me to be far more proactive as a network administrator than I can with just a simple network monitoring tool.
Absolutely. I think network monitoring tools help engineers react, right? And engineers hopefully get an event and alerting system before a customer is calling them. But the steps that occur after an event happens are usually very manual. So it allows them, I will say, to one, react very quickly, or in the case of sort of some of our triggered API diagnoses, be very proactive so that by the time an engineer even arrives on the scene, they are already armed with all the information they need, the map of the problem area, the performance diagnosis, and a set of executable diagnoses that would run against that path.
From a value prop perspective, one of the big things I'm seeing here is the potential for reducing the amount of downtime, which is going to basically mean that we're going to lose less money if we have to go down for some reason.
Absolutely. I think network downtime is kind of a scary thing for network teams. NetBrain can help in two ways. One, when the network does go down, we can help you respond a lot quicker. So sometimes it can take hours or days to respond. You can turn that into minutes with NetBrain. Number two, even reducing the risk of a network outage. So it turns out between 40 and 50% of network outages are caused by some sort of network change, usually a manual network change that had an unintended impact. NetBrain can be used to validate the impact of a network change, thereby reducing up to 50% of network outages in the first place.
So if I'm a network administrator and I want to try NetBrain, how hard is it to get it deployed?
So it's relatively simple. So we use a virtual machine, like a Windows virtual machine, to do a network discovery. So it needs access to your live network via SNMP, Telnet or SSH. And that neighbor walking discovery algorithm that collects data from the network happens very fast, a couple thousand devices per hour, building a very rich, what we call data model of the network. So it's a scalable server architecture. It's a thin client deployment, so that there's no rich client need to be installed. It happens in a web browser, and usually teams are up and running in just an hour or two.
Very good. Jason, thank you for having us today.
Thanks again, Scott.